Hello guys, welcome to Ice Education. Mr. Koso, today when I opened my phone, I received a YouTube notification from my own YouTube notification saying like there's a video that I posted and what so. It was kind of exciting to see myself there. It's nice, eh? Now, here we go. What's the question? The question is saying for the rotational system below, find the transfer functional g of s, which is theta ls over ts. Theta ls over ts. So let's go. Now, what is important when we're dealing with gears like this, Mr. Koso, Mr. There is this relationship. Let's say I have n1 theta 1 is equal to n2 theta 2. Now, here's the thing. This is how easy this thing will be, guys. Uh, do you know what are gears here? The function of gears here. Let me do this. Hey guys, please, you can update your payment. You know, need money to sort out some few things. Okay, Mr. Koso, for instance, this is what's happening with gears. If we have one here and let's say another one here, the thing that is linking them is the rotational of turn. So the aim of this our study is to make this to be one, to simply have one line like this. That's the whole idea in everything that we are doing here. Now, how do you do that? You need to do it according to what you want to solve. I don't know if I'm making sense. What I mean is, when we had this question, they want the transfer function of theta L, is it theta L? Yeah, theta L over T. Now, do you agree that this one is N1, N2, N3, and then we have N4? Now, what's the aim, guys? We want to solve for the transfer function, but here we have gears. And yet again, the gearing things given to us here, it is simply to get everything to be as one gear. That's the moral of the story here. Now, how do we do that? We do that through this crucial relationship of this one. This is how it is done. Now, it is important to know which one do you want to make as, can I say, subject of the formula. Look, I have the first guy here. I have this rotating object. Do you agree that this one we can take it as J because it is a rotating object? This is a damper. It is C and this is the spring. Yes. God. Or is it everyone? No, guys, she maybe she should try to check the side because I can see. No, no, I thought maybe I was not sharing, but. Oh, you see it now. Oh, thank you. Thank you. Okay, if you look at your test, you were given something simpler as this one. You were given something like this, and they wanted you to solve straight for the transfer function of a rotating object like this, where you guys had to. Let me check again. This is the sick test. This is, sorry, but this is what you got for your test. It was a simple object like this, and you were asked to solve for theta 1s over gs. So here what you did was simply to solve for whatever you guys did there to get JSC in terms of Laplace, and then you make it equal to t like we did last time here. I think there's a video about it on YouTube, but if we don't get it, since it's revision, we will make sure that we get it. So here's the thing, this simply means that when you have a torque applied, you guys know what does it mean. It means the system 1 is equal to the torque, system 2 is equal to... Anyway, I'm sure you guys did well about it. But what's happening here is, remember, what we do have here, we have gears leaking, but we want it to be 1. And like I said, what I need is theta ls. I need theta ls to be over chi. So I cannot make theta... Okay, this is the ionic thing. I don't know how to... I want to say it in the easiest way. And I believe that you understand what I mean. Do you guys agree that there's supposed to be a theta 1 here or theta somewhere here? But anyway, it's fine. We'll deal with it. Do you guys agree that if I want to move theta L here, let's say to here, do you agree that everything here will be in terms of this theta 1? I want to explain it in a way that can make sense easily. Now, let's do this. Do you agree that I'm between this gear and this gear, and I have to make one to be linked to the other one? That's the first thing that I want you to get. But the other thing is, I have to link it in a way I get what I want. I don't know if you see what I mean. So, if I link theta into this, let's say for instance, I have this relationship. Let's say I have n3, let me call it theta 3, to be equal, this one is n4, let me call it theta l. Do you guys agree that if I make theta L subject of the formula, what will I be having? I'll be having n3 over n4, everything to be theta 3. In this instance, theta L is disappearing. This is the first thing that I want you to get first. Remember guys, in these gear things, this is the only relationship that we need. As easy as that. Now it's a matter of you knowing what you need to do. When I do this, it is simply mean that I am linking this theta L inside here. But if I do this, it is wrong under this case. Why? Because the question wants theta L over chi. But if I do like this, theta L is disappearing. So what does that mean? It means I have to link this guy coming here. So it means you should make your n3 subject of the formula. I don't know if you see it. Your theta 3. So which will be n4. Yes. Is that a question, guys? It's Andile asking if you are recording. Yes, the class is being recorded. I can double check. Yeah, it's been 8 minutes since we are here. And yeah, we'll have a voice for this one. Everything will be perfect. And we should be fine. Close like that. Okay, and guys, remember, like you did on test 1, for each and everything of this one, you need to get the Laplace of it. Okay, let's do this. Let's do this, Mr. Koso, so that you see how easy is the gearing, guys. Now, I'm gonna focus on this one here. Do you agree? If I get the Laplace of it, what will I be having here? I will have js square. Remember I said for this one, everything is taken as in initial condition. Remember, I will have js square. Do you guys agree? Now, I will have plus 2s. This is for the guy on top here. And then plus plus 3. Now I can call all these guys here to be in term of which theta. Whatever theta is here, we can name it, let's say, theta 1. Let's call it like that. Now here's the thing. You have gearing. For you to get the transfer function, you need to... Yes.
I'm a little bit lost. Please just explain from straight, you see. What's happening? Sorry for
No,
the
no,
back.
you don't have to be sorry, my brother. My aim is for me to make you understand what's happening, my brother. So you don't have to be sorry. I think I'm gonna take an easy. Let's do this. Before I move to the gearing, I'm just gonna remind us about something quick here. Mr. Koso, do you remember this one? How this was solved?
Yes,
And
I
then,
do remember that.
yeah, this is even was your test, eh?
Mr. S, you remember I showed you that way of like a matrix form or something. You remember? That one is easier than the way that you usually do it.
The matrix form that you sent me, like so you said Sosinando did.
Yes, so Nando did it in SARS.
Okay? Okay. So you understand the matrix form, Mr. Koso?
Yeah, maybe the other people can also share their mind. Maybe they want that one, but I was just suggesting
No,
that.
yeah, it's good, no,
that
but it's good to suggest, but yeah, I haven't like look at it, but it seems still and short. It seems very cool and short, my brother. But anyway, I'm gonna have a look at it before tomorrow's class. That method. But when you did this, you get to this one, right, Mr. Kotso?
quick.
Quick, quick. Okay, here's the thing, Mr. Kotso and Mr. Endani. Under this case, we have everything to be under a linear line. Do you guys agree first? When you see this, Mr. Kotso. Now,
Yes, yes.
when we have gearing system, we don't have a linear line. You have up and down, whatever the shape that you can get there. Now here's the thing. When you are solving this using the gear method, the first thing to do is to make it to be linear. It's more or less like, let me just take an electrical example. If you have resistor in series, what do? You make them one first, right? And then you solve whatever you want to solve. If you have resistor in parallel, what do? You make them one first and then you solve whatever you are solving. I know electrical is not our field, but that's the best example that I can give right now. In this of system that we are doing here, when we have gearing, simply what they mean is we have to make this, you see, like you have 1 2 3, you have to make it be 1, and then you solve for the problem the way we used to see it. Now here is the thing. When we have gearing, Mr. Koso, the relation that brings us to be 1 is the relation between speed angle and speed angle. So what do I mean? For a gear, whenever you have a gear, you have, let's say, the number of teeth of the gear, which is not important here, but you have the speed of the gear at which it is rotating, and you also have the angle of rotation of a gear. So that relation that each gear has, it is the one that we use to link to make it one. That's the principle about this. If you understand how to solve when it is 1, then it becomes easier here. Why? Simply, what we are doing here, we want the gear to be 1. For instance, Mr. Koso, This is what is happening. I do have one gear, let me call it one, two, three gears, but I want them to be one. That's my aim, so that I can solve for my transfer function. Now, how do I know which one to do? The question tells me, the question says they want theta L over chi. So I have to make sure, Mr. Koso, when I'm doing my transformation, theta L is the main guy, is the subject of my formula. That's what I was saying, Mr. Koso. If I have a relation, let's say I have n3, forget about the shape that we have here, n3, theta 3, n4, let's say theta 4. Now, the question is telling me, Mr. Koso, that we need theta 4 over, let's say, chi. Do you agree that under this case, if I want theta 4 to be to still stand there, it cannot be subject of the formula in this relation? I don't know if I'm making sense. Because if I make theta 3 subject of the formula, I will have n4 n3 multiplied by theta 4, Mr. Koso. Now, what does it mean? It means in the expression where I have theta 3, I will simply replace it by this expression here. Then in this case, I'm having everything in theta 4. I don't know if I'm making sense.
Miss Lars, can you please repeat that part again?
Yeah, I'll repeat, my brother, I'll repeat. This thing is easy. The problem that I'm seeing here, I think I'm having a problem of transmitting the way I see it in my mind. But let me retry again to see what I mean, guys. Here's the thing. I think if I draw, I'm gonna have a good. I have one gear here, and I have another one here. Okay, by the end of the day, I want them to be one. When I say I want them to be one, I want them to have the same theta. That is what I mean. Let's say this gear here is theta 1, and then it has n1. This gear here is theta 2, and then it has n2. Forget about what can be inside here, but let's look at this one first. I go with my relation, saying that n1, theta 1, that's the link between them, is n2, theta 2. Do you guys agree? If I want everything to be in term of if I want everything to be in term of theta 1, then I have to make theta 2 subject of the formula in the relationship. Do you agree with that, Mr. Koso? If I make theta 2, do you guys agree that I will be having n1, n2, and then this one here will be theta 1? So what does that mean? It simply means wherever I will see a theta 2, I will now replace it by this theta 1. So it means now everything is theta 1, theta 1, theta 1. Now that's the thing that I was saying. For you to know which one to make subject of the formula, you need to know what does the question need from you. If the question says that we need to have, let's say, theta 2 over chi, therefore, on my relation here, theta 2 cannot be subject of the formula. Theta 1 therefore will be, so that I can have everything still remaining with theta 2. That's what it means. Now I'm going to add a new rule, but for now, before I add the new rule, is this making sense to you first?
Yes, I see. We're getting it.
Okay, if you don't get it, you don't have to forget about it, but you have to ask me, please. That's what I'm here. Now, here's the thing, Mr. Koso. We are solving this question. They want the transfer function. Here is the rule. Now, I asked the question earlier. I said, if I want theta L, do I need to bring this one here or this one here? Let's forget about that one first, but let's see how it is done. We're going to solve for the Laplace of each cases first. I believe we're on the same page. I am starting with this one. Please start with the one that has the talk last because we always equate it to that one. You start with that last. Now, we are here on this element, Mr. Koso. If we still remember, if we have to use this one solving the Laplace, we know that this one is J. I can call it JS square. It's Laplace of it. All conditions are zero. That's the reason why we are using it like this. And I think I've explained this before. Plus 2s plus 3. So remember, I can replace the j here by 1. That's what it means. This is what we do have on gear 1, Mr. Khotso. This is what we do have. It is this. So if I want, because there is no theta provided to me, let me call it uh, theta 3, just for my sake, because I have n3 here. Let me just call it theta p. Now, this is what's happening. I'm moving to this guy here. If I want to solve for the Laplace of it, remember it only has a damper. So definitely what I can do, I can simply write 0,04 s. This is for theta L. This is... Yes, my brother.
Can you please explain this three again, this whole equation of s squared
Or
plus
the whole
2s?
equation of s squared plus 2s. What you are doing,
Yes.
we are simply solving for Laplace. And like we remember, when we have okay, the general formula of the Laplace say that if you have, let's say, the x dt square plus dt, I'm not sure what am I writing here. Mm. But the general, let me not write the dt, the what. This one is kind of confusing me now. But what I mean is, if you have a second derivative, let's say y second plus y prime and plus a constant, you want to solve the Laplace of this thing, of y second y prime plus 1. From the principle of math, there are formula provided to it. One of them says that when you are solving for y second, the answer is, they said, it is, where is my textbook? My math 3 textbook. Let me double check before I say something. Okay, they said it is uh, s square. It is s square y of s. That's what they mean. And then they have initial condition that says minus s y0 minus y prime of 0. And I said here, when we are doing this Laplace, all these initial conditions are 0. So what is important to us, what matters to us, is s square y of s. That's one of the reasons. When it comes to j here, j is taken as the second derivative. That's one of the reasons you only see s square, because the constant next to it is 1. Now, if you look at the derivative of y prime, the formula says for y prime, it is, what is it again? It is s, y of s, following to minus y of 0. But remember, all these initial conditions are 0. That's one of the reasons we only have a s here, but we add with the constant next to it. And again, if you have a constant, Laplace of a constant is simply y of s. That's the reason why we simply take 3 the way it is. Yes, my bruiser. That is why I'm writing it like this. You don't have to write it like this. The only reason why I'm writing it step by step like this is for you to see how we are moving to get to the solution. But once you get comfortable to it, you can move straight. You get the Laplace, you move, you move. It is not difficult, guys. And remember, there's always this sentence that I say, there is always a first time in anything, Mr. Khotso. There is always. that you do in life. And after the first time, you become an expert, my brother. But we know, first time you don't really. It depends, my brother. You can do it great first time, or you struggle like me, and then you get it right. Okay. Um. Wait. Before I move, are you guys with me first? Because I need to know. Hello, my leader, Mr. Koto.
Yes, it's good.
Okay, guys, let me move straight to the topic to see what it is now. Here's the thing, guys. We have the relation. Remember, from here, what we do is, Mr. Koto is, I'm writing right here to see what's happening. We have theta 3 and we have theta L. Remember the relation. The relation says n3 theta 3 to be equal to n4 theta 4. Now, what do you want? We want everything to be theta L according to the question. I believe that on this we are all together. If we want theta L to be if we want theta L to be subject of the formula, it means that theta 3 here should be n4 over n3 theta L. Now remember, I said I'm going to include a new rule after this one. So this is what happened, Mr. Kotso, Mr. Kevin. Basically, what I need is I want to make these two to be together. If you understand what I'm trying to say is what we're going to have is going to be N1. It's going to be another gear which is linked, where everything here is linked. And remember, we have N2 here, so that at the end we can link these two here. It is more or less like you are reducing in the same denominator. Am I making sense when I say denominator? But anyway, it's reducing to get an easy expression. So now this is what happened, Mr. Kosu. If I do want everything to be the same, so how do I do this? This is the thing that I was saying. I want everything to be theta L. Now, where there will be theta 3 here, it now going to be N4. Now, that's the crazy thing about this one, guys. When it comes to this, what you do, I think I'm forgetting the reason why, but this is how you need to do it. You square your speed when you are moving from one side to another. What do I mean by that? I want everything to be one. What I will have, Mr. Kotsu, is going to be s squared plus 2s plus 3. Instead of writing theta 3, I will write n4, n3. I need to square this. You square only when you are moving between element without torque. I hope I'm making sense. Element without torque, I mean where you don't see an external force applied. Square, what you have is theta L plus 0.04 s theta L, Mr. Koso. Now, what we have done is we have made everything to be in terms of theta L. But what has helped us to link, it is simply this relation. And I implemented a new rule. Whenever you are moving to make something to 1, you square the relation of the speed. And I'm repeating again, the square is only applicable for the element without torque or external force. So what does that mean? What did we do? We simply reduced everything here to be this expression. This is what is happening, Mr. Koso. That's one of the reasons why you are given this speed here. You have n4, you have n3. You can type them under the calculator. Let's see how it's done. And the good thing is what, guys? You don't have to show this drawing. You can just solve straight. So it means here, you have s squared plus 2s plus 3. You pick up your value. What is n4? N4 is 10. What is n3? It is 50. Now they are being squared. Now you have theta L plus 0,04. It's 4, right? Theta L. So now we are writing this expression to be in to an easiest form, Mr. Koso. We can take our calculator. Remember, we have theta L here. Sorry, there is an S here for this one. So the expression with S, you can add them to be 1. So guys, what is the relation between 10 and 50? And before I move again, I need to make sure that we all on the same place. Do you understand? Do you understand what's happening, guys? Please be honest with me.
So there's no equal sign, nothing. Just doing this equation. Or it's still gonna be close to something.
No, the m of it is going to be equal to to the torque that we are looking here, my brother. Remember, when we are doing what am I thinking? What am I thinking? Mm, everything is supposed to be equal to this torque. But at the end, we have to link this part to this. No, I'm just looking of. That's a good question. Better way of writing this. Okay, here we only have the final answer. Find the transfer function g theta 4 over this. Mr. Kotso. Okay, here we're doing it system by system. This to be equal to 1. Now, in this case, when we linking to gear, we do it directly. We don't have to. We do not have to do it separately, my brother. We don't. That's a great question, my brother. So when we do this, normally everything is supposed to be equal to the torque of chi the way it is. But now we are not yet done. We are not yet done. What we did is, my brother, we link these two to be one like this. Now what we have to do, we need to link now N2 and then N1 here. In such a way that we need
So,
to. Sorry, you're saying?
it's okay.
Are you sure, Babuza?
It's,
Cosi for life, Cosi for life. Okay, Babuza, this normally is supposed to be equal to chi, the way it is like this. Sorry, guys. Now, the next thing is, Mr. Koso, what do we want to solve? We want to. What do we want? We want theta L over chi, but remember we have the last link here. Remember everything here became theta L. And then here, let me call it theta 1. if we have to move with n1, theta 1, to be equal to n2, theta L, because everything become theta L. That's what we did when we moving. That's what's happening. But remember, we want theta L still to be subject of the formula. So in this case, we're going to have n1 to be, theta 1 to be n2 over n1, and then to be theta L. So what does that mean? Under theta 1, do we have any other thing here? No, we don't have. We only have something to be equal to the top. But because we are having a shift, something moving into another, we need to apply the rule of square now. So what does that mean? For this expression now, Mr. Koso, what we're going to have will be s squared plus 2s plus 3, without forgetting the past relation that we had, 10 over 50 square. Now multiply now again, because remember, now you are moving something else in. Now the ratio of speed n2 over n1 square now. What is n2 over n1? 33 over 11 square, because you still need theta n, plus here you're going to have 0,04. S now is going to have 33 over 11 square. To be equal, that ratio is also applicable here, but remember I said we only square for the part where you don't have an external force or a torque. Under this case, we're gonna take the ratio the way it is. We simply use the ratio n2 over n1, which is 33 over 11 torque of G. I know it's seeming a bit tricky, and I feel it. Yes, I can feel it, Mr. Kevin.
It says we only square it when there is no torque. Or
Yeah, that's what I mean. In the place where you are not having an external force or a torque. Like this one, and this one is moving to this one, but remember, because we have a torque here, when it comes to the torque, we only gonna write our speed, our speed relation here. And now I'm thinking I need a better way to explain this. I need a better way, Mr. Kevin. I need a better way. And I'll find it.
it's fine. No problem.
And this is just it, guys. This question, Mr. Kosu, this is how you solve it. What you do is you make theta L um, you make theta L subject of the formula. That's what's happening here. You're gonna have everything remaining here, that the way you have it, Mr. Kosu. S squared plus 2s plus 3. But remember, you need to calculate everything that you have here. You need to add them to have a simple expression. I know it seems a bit crazy, and I can feel it by the way I'm explaining this, that this is not how I want my message to pass. But this is how you solve it. And I will pop out with a better way by tomorrow. Even by now, the more we try question, I'll get it easier to explain it again. Now we have 33 over 11 torque of chi. So to get that relation, Mr. Koso, you make theta L over chi out of the formula. So you'll have 31 over 11 divided by everything here. Let me try to call this everything to be alpha. If you do that, you have solved the equation. Now I want us to do something else. Not something else by something else. I want us to try I think this one would be a bit complex. I need something that can be easier to understand. But we're gonna do this one. Don't worry. But for now, what I need is to pick something that will be easy for you to see first what we are doing. I don't know if I do have one here with me. Mm, Starozzo. Mm, yes, it's time on, time over. Oh, shit. Hey, Mr. Kotso, are you with me, my brother? What's happening? Hey, Mr. Kotso, are you with me?